Welcome to all of you, my dear students. Today, I am going to start a solution class, that means a solution series regarding on MCQ questions of engineering math first sem. So, my today's chapter is double integration, a most important chapter, the first year of engineering, and I hope that this solution series will help you to understand each and every concept in mathematics, and this also will help you to solve any type of typical type or easier type, whatever it may be, any type of problems. So let's start with some problems, MCQ type based problems from double integration. So what today's chapter is double integration. So here I am going to explain the formulas using the problem, right? So first of all, I am writing some problem and discussing the solution on that problem. I will tell you all regarding formulas, right? So let's start with problem. I think this method uh, will be more helpful for you. Our first problem is if r equals to f of theta be a curve in polar coordinate, right? If this be a curve in a polar coordinate, then area bounded by the curve, then area bounded by the curve so area bounded by the curve and the radius vector, and the radius vector theta equals to alpha and theta equals to beta is given by. So there are four options. The first option A is integrate alpha to beta r squared d theta. Second option B, sorry, it will be alpha to beta r square by 2 d theta. Option C, integrate alpha to beta r theta d theta. And option 4 D, none of this, right? So let's discuss it. How can I solve this problem, or what will be the right choice, right answer? So first of all, look at this. This is the polar form, right? This is the polar form of a curve r equals to f of theta format. So to solve this problem, now here I am drawing a circle. So this is a circle with center at origin, right? To center at origin, that means suppose this is 0, it may or may not be origin, but this is the center. Center is O. Now here I am taking a sector. This is a sector with a small angle d theta. This angle is d theta angle, right? This angle is d theta angle. So this total rotation, the total rotation is 2 pi 360 degree. The total rotation is 360 degree. So Now look at this figure. This angle is d theta, and this perimeter of the circle will be 2 pi r if r be the radius of the circle, and the area is given by pi r square. This is the area of the circle. So here this 2 pi angle forms the area pi r square. So 2 pi angle forms the area pi r square. Right? Now here the angle d theta, our angle is a small angle d theta. This forms the area pi r square by 2 pi d theta, right? So this d theta angle makes the area pi r square by 2 pi d theta. So after calculating, we will have r square d theta by 2, right? So it will be r square d theta by 2. Now this gives the small area, this shaded area, right? So this area dA, suppose I am writing this area as suppose dA. So this dA is given by r square d theta by 2, right? So dA is given by r square. Now I am erasing this first line. So here dA is given by r square d theta by 2. Now integrate both sides, we will get the total area, and which is given by integrate r square d theta by 2, right? So what will be the right answer? Therefore this B will be the right answer, right? This is our right answer, right? So this is the first problem. I think you all have understand this. So if you have any problem regarding understanding this problem, so just pause the video and see the video again. Now I will go for the next problem. So first of all, I am erasing this, right? So now go for next problem, the second problem. So this is our second problem. Now let's try to do this. The value of, we have to find out the value of this integration, double integration, right? It is a very easy problem. So since the both limits are constant, some constant to some constant, so I am writing this integration first of all, and this is dx dy. So you can integrate this interior part with respect to either dx or dy, whatever it may be. You can integrate either this or this, right? Because this actually forms, these two limits together forms this region, this rectangle. This is our 0, 0 point. This is our 1, 0, 1, 1 point and 0, 1 point, right? So this actually forms this rectangle, and so that's why here I am taking the integration of this interior of this function with respect to x. So it will give with respect to x, that means keeping constant y, x square by 2 plus yx, right? So this is 0 to 1, and now putting the value for x, it will be half plus y, right? Half plus y dy, and half y plus y square by 2, 0 to 1. Therefore the value will be half plus half, that means 1. So right option will be 1. A very easy problem. The answer will be 1. Now next, go for the next problem. So our next problem is, 0 to pi by 2, integrate 0 to pi sine x plus y dx dy. This is also a very easy problem, and similarly uh, we have to integrate this entire portion with respect to x. Then integrating, you will get we will get 0 to pi by 2, right? So I'm changing this, so it will be 0 to pi by 2, and this is our minus cos of x plus y, and the limit will be 0 to pi, and since I am differentiating with respect to x, so it will be remaining dy. Now putting the limit, so cos pi means just putting here x equals to pi, so cos pi plus y means it will be minus cos y, right? So minus of minus cos y means cos y, plus the next will be cos y, and integrate 0 to pi by 2 dy. So 2 integrate 0 to pi by 2 cos y dy. Therefore 2 sin y 0 to pi by 2. So pi by 2 means 1 and 0 means 0, so 2. The right answer will be 2. Therefore the value of this will be 2, right? So you are given some options like 2, 3, 4, 5, 6. So among that, the right choice should be 2. Now I will go for our next problem. Now look at the next problem. The next problem is 1 to 2, 0 to y dx dy by x square plus y square. So here the first limit is some constant to constant, the next limit is some constant 0 to y, and dx dy. So here you should integrate with respect to dx first of all, right? With respect to dx, and then sorry, with respect to not dx, with respect to x, and then integrate with respect to y. Therefore 1 to 2, right? 1 to 2, and integrating it with respect to x, then keeping this constant, and if I keeping this constant, it will be 1 by y tan inverse x by y. We all know this formula, dx by, this is 1 by a tan inverse x by a plus c, right? So it will be this, and 0 to y dy. Now putting this 1 to 2, now putting the value of x, so 1 by y tan inverse 1 means pi by 4, and next will be 0 dy. Therefore pi by 4 1 by y dy, 1 by y dy means it will be log y, and log y of 1 to 2, log 2 means, log 1 means 0, so minus 0, that means the answer will be pi by 2 log 2, right? The answer will be pi by 2 log 2. So now I will go for the next problem. If if you are feeling any doubts, then, or any problem, then you must comment in the comment section of the video, and I will obviously try to solve all types of problem. So now start with the next problem. I am writing the problem. Double integrate over some region R x sine x plus y dx dy, and here you are given the region R. This is the region as 0 less equals to x less equals to pi, and y lies within in this region. Now look at this region. This is actually represent a rectangle, right? This actually represent rectangle like this. This is our origin, this type of rectangle, and x varies from 0 to pi. X varies from 0 to pi, and y varies from uh, 0 to pi by 2, right? Y varies from 0 to pi by 2. So this, it will be pi by 2 point and 0 pi by 2 point. So whatever it may be, now I'm trying to solve this problem. So rewrite it with the limit x varies from 0 to pi, and the limit y varies from 0 to pi by 2, and x sine x plus y dx dy, right? This is x. So now I am integrating this with respect to x. So integrating this with respect to x, we will have minus x cos x plus y with the limit 0 to pi by 2 dy. Now putting the limit, we will have integrate x sin x plus x cos x dx, right, with the limit 0 to pi, with this limit 0 to pi. So the next line will be okay. So in our next line, now here I am doing by parts for this part and this part. So for this part, look at a simple by parts calculation. Minus x cos x with limit 0 to pi, right, with limit 0 to pi, and then minus integrate 0 to pi, it will be cos x dx. The next will be plus x sin x 0 to pi. So this is the by parts for this part, and now I am starting the by parts for this part, right? So this is the by parts for this, and this is by parts for this part. Now minus 0 to pi sin x dx, right, sin x dx. Now look at this. Look at this. Now putting the value of x as pi, so it will be pi, right? It will be pi, since we all know that cos pi means -1, and this is pi. There are another one, so minus minus plus, it will be plus pi. A simple calculation, and then minus something 0, and then minus sine x with the limit 0 to pi plus x sin x 0 to pi. So the value of this will be 0, minus the next one cos x with the limit 0 to pi, right, and this is 0. The value of this limit will be 0, and this is our pi, and the value of this will be -2. So this is the answer of the given integral. Therefore the answer is given by this equals to pi -2. This is our answer, right? Okay, now go for the next one. So our next one is integrate 0 to 1 integrate 0 to root 1 minus x square xy dy dx. Okay, now solve this. 0 to 1. Now I am integrating this with respect to y. Now when integrating with respect to y, then keeping x constant, therefore it will be x y square by 2 with 0 to root 1 minus x square dx, right? So this equals to 0 to 1. Now x by 2 1 minus x square dx, right? So it will be 0 to 1 x by 2 minus x cube by 2 dx. This is x square by 4 minus x 4 by 8 with 0 to 1. Therefore, this is equals to 1 by 4 minus 1 by 8 equals to 1 by 8. Therefore, the answer will be 1 by 8. This is the answer. So, okay, that's it in my today's class. That means the first class of this solution series. I think I hope you all are enjoying my class, and if you have any doubts, then you must comment in the comment section of this video. Okay, thanks again all of you. Keep supporting, and if this video helps you a little bit or something, then you must like and subscribe my channel SD Mathematics, SD Maths. My channel name is SD Maths. So please like and subscribe this. Okay, I'll stop here.